Section 4.5. So let me grab a picture of a sine and a cosine graph. All right, and we've talked a little bit about these before, about some of the ideas from today. So here's a graph of a sine function and a cosine function. We know, we've talked about this before, we know that the period of these functions is what? When do they repeat? 2 pi. We go around the unit circle and we repeat. So our period is 2 pi for both of these. Our range. Our range is what for both of these functions? Right? And we can have an equal in there also because sine and cosine equals -1 and +1. So -1 less than or equal to y less than or equal to 1. So we could just say -1 to 1. So that's our range. So we go up here to 1, down here to -1 for both of these. And if we look at this graph, we see that we have over our period tells us our function, a graph of our function is going to repeat every 2 pi units. So here where we cross the x-axis going up, in another 2 pi units we're going to cross the x-axis going up. If we're here at a peak, we go from peak to peak in 2 pi units. If we're here at a trough, at the bottom, we go from the bottom to the bottom in 2 pi units. So we can pick any point on the graph, and when we're back at that same point, that exact same point, that's going to give us a period that's going to happen over a period of 2 pi if we have not doing anything else to our function. And every quarter of a period, we either have a maximum, an intercept, or a minimum. So I'm going to say important points. Every quarter of a period. So for these particular sine and cosine functions, when we just have the plain function, nothing done to them, it's going to be every pi over 2 units. So at pi over 2, I start at 0, at pi over 2 here for the sine, I have a maximum. I go another pi over 2, I have an intercept. Another pi over 2, I have a minimum, and another pi over 2, I'm back to an intercept. So those key points, the maximum, the intercept, and the minimum, happen every quarter period. Same thing with the cosine, but the cosine starts up here at a maximum and goes down to an intercept at pi over 2, minimum at pi, 3 pi over 2, intercept again, and 2 pi, we get a maximum. So, and this will be true of any sine or cosine function that we graph. A quarter of a period is going to give us key points. Now before we start doing things to our function, I want to show you how these graphs come from the unit circle. So here's a little animation. Here's my unit circle. We're starting here at 0 degrees or 0 radians. And this is my graph. I'm graphing the y coordinate, the sine. And as I start here at 0, my graph goes up to 1 at pi over 2, goes back down to 0 at pi, goes down to -1 at 3 pi over 2, and then back to 0 at 2 pi. So that's how our function is generated from the unit circle. The length of the red segment is the y-coordinate, is the sine of the angle. And I can do the same thing for cosine, except cosine would start at 1 and go down like we graphed here before. So that's where our graphs come from the unit circle. All right, so let's start doing let's make this a little more interesting and actually do some things to these graphs. So the first thing we want to talk about is the amplitude. So we're talking about graphs or functions for now that look like a sine x or y equals a cosine x. So when we did our graphing lab, what did that a do to our function? We stretched it vertically, or if a were a fraction or a decimal, shrunk it. So this gives us a vertical stretch or compression. And what happened if a were negative? What is it, Andrew? What did you say? If a were negative? Flipped it over the x-axis, right? So this tells us it affects what it does vertically. So we get a vertical stretch or compression. If a is negative, we get it flipped over the x-axis. We call the absolute value of a is the amplitude. That's the amplitude of our function. And what the amplitude tells us is how far above and below, I'm going to say the equilibrium point, because we'll start shifting our function up and down, so it's not going to be above and below the x-axis, it's going to be above the equilibrium point. That tells us how far above the equilibrium point our graph goes. And the amplitude is always positive. We don't say the amplitude is -2. We would say the amplitude is 2, and the negative would flip us over the x-axis. So let's look at an example of graphing a function by hand where we're changing the amplitude. It's pretty easy. So if we have y equals 2 sine x, all we're doing is putting that 2 in front. So what is this going to do to our graph? Stretch it by 2. So nothing else changes. And we're just using what we know about transformations of graphs. So this is how I would sketch a graph by hand. I would say that's 1 and that's 2, -1, -2. I know my period is 2 pi, so I'm going to put a mark out here. This is going to be 2 pi, and I know that every quarter of a period I'm going to have important points. So that's pi. And so for this one, a quarter of a period is pi over 2 units. The other thing that will happen as we start doing these graphs is hopefully you'll get very comfortable with fractions, because we'll be doing these in multiples of pi over 2, pi over 3, pi over 6, etc. And then I know that my sine graph starts out here at 0. It goes up to a maximum here. If I couldn't remember, I could plug in pi over 2 and say, oh, sine of pi over 2 is 1, and I'm multiplying that by 2, so that brings me up to 2. It's going to go to here, and I'm just going to move my 3 pi over 2 over a little bit, because my point goes down here, and then back here to 2 pi. And then my graph would look like so. And there's one period of my graph. And if I needed to sketch more than one period, I could just continue by pi over 2 units and graph another period. It's going to do the same thing, repeat the same pattern in the next period. So questions about that? All right, so what would happen if we had y equals 0.4 cosine x? What would that graph do? It would start, so our maximum and our minimum would be at 0.4 and negative 0.4. So I can sketch out a graph of this really quickly. I know that my period is 2 pi. I haven't done anything to the period. Every quarter of a period I'm going to have important points. And instead of starting up here at 1, I would start down here at 0.4. And that'd be negative 0.4. And my cosine would start here, go to here, go down to here, back up to here. And there would be one period of that function, just compressed by a factor of 0.4. And if I needed to continue, I could plot out points in pi over 2 increments and plot more points. So questions on changing the amplitude. And if if A is negative, then our graph just flips over the x-axis. All right, that's pretty easy. Next we're going to talk about the period. So for these we're looking at our functions y equals a sine bx or y equals a cosine bx. So we know what a does to our function, vertical stretch or compression. When we did this graph, what did b do when we had a b in there? Do you remember? Okay, so it's going to change the period. So we get a horizontal stretch or compression. So the b gives us a horizontal stretch or compression. So it changes the period. And do we remember if b were greater than 1? So say we had a sine 2x. Did that give a stretch or a compression? That gives us a compression. So if b is greater than 1, gives us a compression. And if we have a fraction, so 0 less than b less than 1, we get a stretch. So if we have some kind of fraction, we get a stretch. Well, let's look at how we can figure out how much it stretches or how much it compresses, and how we can then graph those functions. So we'll start with y equals a sine bx. We can go through the same process with the cosine function. It's really the same thing. So I'm going to say y equals a sine bx equals 0 when bx equals 0. When I plug 0 into my sine function, I get out 0. So this tells me that x equals 0. So my a sine bx equals 0 when x equals 0. And a sine bx equals 0 when I go all the way around the unit circle. I repeat. So when bx equals 2 pi. So whatever's in there, when it equals 2 pi, I've gone all the way around my unit circle. So this tells me when x equals 2 pi over b. So this function completes one cycle between 0, x equals 0, and x equals 2 pi over b. So the period is 2 pi over b. So when I have y equals a sine bx or y equals a cosine bx, our period is 2 pi over b. So when b is greater than 1, my period gets smaller. When b is a fraction, my period gets longer. And when we go to graph these functions, we go through the same process. We still have key points every quarter of a period. So we take our period, divide it into 4 equal pieces. We're going to have a maximum, an intercept, or a minimum at every quarter period increment. We just start with our new period. So the A, our amplitude, stretches vertically, compresses vertically. B changes our period, and it compresses or stretches horizontally. So let's take a look at an example using B, using a vertical or horizontal stretch or compression. So any questions on how we came up with how the period changes? Okay. So we have y equals, for this example, cosine 2x. So our amplitude is 1. Our period is 2 pi over 2, or pi units. Our period is pi units. So this function is going to repeat every pi units. And we're going to have key points. Every pi over 4 units. Every quarter period we're going to have key points. So let's sketch a quick graph here. This is going to look just like my regular cosine function. My maximum is going to be 1, my minimum is going to be -1, the amplitude is 1, and I'm going to label this as pi. And I'm going to divide this into 4 units. That's going to be pi over 2, pi over 4, and 3 pi over 4. And my cosine graph is going to start up here at 1. It's going to go to there, to there, to there, and then back up to here. So there would be one period of that cosine function. If you can't remember what value your cosine function is going to have, plug this back into my original equation. So if x equals 0, I know cosine of 0 is 1. I plug in pi over 4. Well, 2 times pi over 4 is pi over 2, and the cosine of pi over 2 is 0. So we can always calculate using what we know about the unit circle. And my normal cosine function, if I graph that in blue, y equals cosine x, it would start at 1, and it would be here, and it would continue on from there. So I'm just adding quarter period increments, and my normal cosine function would be here, like so. And this one would go this. Doing this right? So it would complete twice as many cycles in the same period that the cosine function completed one cycle. So there would be my graph of those two functions. Questions on that? So the amplitude, change the number in front gives us a stretch or compression. The number vertical stretch or compression. The number inside here changes our period, gives us a horizontal stretch or compression. So all the homework, all the problems today have to do with just stretching vertically or horizontally. We're not going to get into shifting vertically or horizontally until tomorrow. I wanted us to practice with this a little bit first. All right. I had to pick and choose these problems, so it looks like more than it really is, just because there's a lot of numbers written out. There you go.